Alright, so we're going to be looking at the graphs of trigonometric curves. So we're going to start off, you should have a copy of this, and we're going to fill in this information, and then we're going to go in after we fill in this chart, and we're going to talk about the domains and ranges. So we have our sine curve, and our sine curve, if we look at these values here, we're basically looking at what is the sine of 0, what is the sine at pi over 2. So if you wanted to make a t-chart, we have 0, pi over 2, pi, 3 pi over 2, 2 pi, and then we did some negatives, negative pi over 2, and negative pi. And we're looking at what is the value at sine at 0, and sine at 0, if we go to our unit circle, sine at 0 is 0. Sine at pi over 2 is up here, that would be 1. Sine at pi is 0. Sine at 3 pi over 2 is negative 1. Sine at 2 pi is 0. Negative pi over 2 just means I'm rotating this way. Oops. Can't see that. I'm rotating this way instead of the other way. So negative pi over 2 would be down here. So negative pi over 2 is negative 1. And then at negative pi just means I went all the way back around. It's 0 again. So when I graph these points, then I end up with my sine curve. So we refer to the point from here to here as one period. So as we keep going, this cycle will continue, and that's why we consider it one period, because it will repeat itself every 2 pi. So we consider the period of sine to be 2 pi. We picked these key points, so we have 5 key points, and we're going to be using those 5 key points for all of our graphs. Okay, so here's our cosine curve, and I have a little bit of a mess up here. Just ignore that. So again, if I do my t-chart, we find out that cosine at 0 is 1, cosine at pi over 2 is 0, cosine at pi is negative 1, cosine at 3 pi over 2 is 0, cosine at 2 pi is 1, negative pi over 2 is 0, and negative pi is 0. Oh, sorry, is negative 1. So again, here's our cosine curve. So again, from 0 to 2 pi, this is considered to be one period of the function. Alright, here's our tangent curve. So tangent, again, you need to think about that unit circle. So our unit circle, this point right here is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So the first value is the cosine, second value is the sine. So we're looking at sine divided by cosine for tangent. So 0 divided by 1 is 0. 1 divided by 0 is undefined. So you'll notice at pi over 2, it's undefined. We have an asymptote at pi over 2. And we're also going to have an asymptote at negative pi over 2. So what we're looking at is one period of the function here. At 0, tangent is 0. So to help us get a better clarification of the graph, we need to think about pi over 4. So at pi over 4, our coordinate is square root of 2 over 2, square root of 2 over 2. So my ordered pair is 1. Or I'm sorry, my tangent is 1. Sine divided by cosine is 1. So the same thing for negative pi over 4. Negative pi over 4 would be here. My tangent would be negative 1. So here's our tangent curve. Okay, so for the tangent curve is repeating from here to here. So the tangent curve has a period, this is considered to be one period, and the period equals pi, whereas on the cosine, our period is 2 pi, and on the sine, our period is 2 pi. Okay, So again, this process will keep repeating itself over and over again. So even though I'm just showing you one part of the graph, if you do put it in your graphing calculator, you'll see multiple parts of the graph, and you can see it repeating itself. So let me show you what we're going to do here. So to get a better idea, we're going to go to our mode and make sure we're in radians. And then we're going to go to our window, and we're going to set our minimum for our x at -2 pi, and our maximum is going to be 2 pi. And our scale is going to be pi divided by 2. And we'll set our y minimum at like maybe -3 and our y maximum at 3. And so, whoops, I forgot to put my graph in there. So when we go to y equals, and we graph sine of x, then what you see is there's one period and another period. So we see two periods of the function there. So you notice how it repeats itself. So from 0 to 2 pi, it repeated itself. Same thing for cosine. If I put cosine in here, you would see the exact same graph. Now notice it looks exactly the same, but it's shifted. So if we focus on 0, sine is 0 at 0, and cosine is 1 at 0. So now if I go in here, let's clear these out, and I put tangent, you'll notice that you've got this curve in there. So I intentionally picked pi over 2 for my hash marks. So you'll notice at the hash marks, you've got areas of the curve that aren't being touched. Those are where your asymptotes are. Okay, so now let's look at cosecant. So if we think about sine as we're looking at cosecant, so what I want you to do is imagine a sine curve here. So sine, because cosecant is 1 over sine. Okay, so imagine a sine curve here, and this is my sine curve. I'm just putting it very lightly, dotted line. There's my sine curve, right? And that would keep coming over here and come back up here. So there's my sine curve. So notice what happens is that when sine is 0, I have an asymptote. When sine is 0, I have an asymptote because 1 divided by 0 is undefined. When sine is 0, I have an asymptote. Okay, so that's why we've got those asymptotes in there. Now then what happens is that at pi over 2, sine is 1. So 1 divided by 1 is 1. So I've got 1 here, I've got -1 and -1. So the curve ends up coming up here and down here like a bowl. So if you can imagine right here, I have pi over 4. And sine at pi over 4 is square root of 2 over 2. So if I do 1 over square root of 2 over 2, that's the same thing as 2 over square root of 2. If I put that in my calculator, 2 divided by square root of 2, I end up with 1.4. So notice on my graph, 1.4 would be up here somewhere. So that's why we're getting these bowls or parabolas on my graph. So that's my cosecant curve. Okay, and the same goes for my secant curve. So for the secant curve, again, imagine that you've got the cosine curve here, and the cosine curve is going to come up here, and then it's going to come around, come around here, and then it's going to come back down here, and come up here, and come over here. So notice like this piece has been reflected, these have been reflected down, this has been reflected, I didn't do a very good job drawing that, and then this has been reflected. And again, when cosine is 0, I have an asymptote. And when cosine is 0, I have an asymptote. So these are my secant curves. This is my secant curve. right, our last one is the cotangent curve. So the cotangent curve, remember, is cosine over sine. So think about that unit circle again. So here's 1, 0, 0, 1. So cosine over sine. This time I'm doing 1 over 0. So at 0, it's undefined. Right? So it's off the screen. So it's 1, 0. 1 over 0 is undefined. Here I'm doing 0 over 1 because we're doing cosine over sine. So 0 over 1 is 0. So at pi over 2, it's 0. And then I can again check that pi over 4 value. And at pi over 4, square root of 2 divided by 2 divided by square root of 2 divided by 2 is 1. So I get 1 here and negative 1 here. So the cotangent curve comes down this way. So the cotangent curve looks just like the tangent curve, but it's decreasing in value. So let's go back again and look. So here's our tangent curve. So the tangent curve was increasing, right? And our cotangent curve is decreasing. Another difference is the cotangent curve starts at 0 and goes to pi. It goes from 0 to pi. So it has a period of pi, okay? But the tangent curve goes from negative pi over 2 to pi over 2. It also has a period of pi. So you have to just keep this in mind. The tangent curve will always span the the y-axis. It'll always cross the y-axis unless I have transformed it in some way. Okay, so look at the next video and we'll talk about the domains and ranges.